Okay, so what if we were to look at the same exact problem, but instead, what if there was a little bit of friction? What if we put the object at the top of the ramp, we let it go, and there was a slight amount of friction? Let's say that mu was equal to 0.100. So we have a little bit of friction. And that means that the object, you know, um, that means that the object will slide, but it's going to meet some resistance as it slides. And how is that going to affect the acceleration? And obviously, if it's got some friction, it's gonna lessen the acceleration, and also it's going to lessen obviously the velocities as time goes on. What I didn't mention last part of this video series is that you have to realize the reason that it's going, whether friction or not, the reason why it's going down the ramp is because of gravity, right? Gravity's pulling it down the ramp. But what's important to realize, it's not all of gravity. It's the x portion of gravity that's pulling it down the ramp, right? Um, the y portion of gravity is holding it onto the ramp, and then the normal force has to hold it back. So realize that the reason something that goes down any incline is because of gravity, but only the portion of gravity that acts, quote unquote, along the ramp. The other portion of gravity acting perpendicular to the ramp is basically just keeping it on the surface of the ramp. And it's kind of weird to think about. I know that, but process that. Now, if I update this situation with friction, I'm going to know that friction is pointing against the way this thing is moving or trying to move. That's important. So if this thing is going down the ramp, friction is going to point, quote unquote, up the ramp. If for whatever reason this object was trying to slide up the ramp, then friction would be pointing down the ramp. And that's not going to change what happens with gravity. So all of this and this is still valid, right? That's friction does not alter what gravity does. But what it will do is alter some of my analysis down here. As a matter of fact, it's going to alter all of my x direction analysis. And if there's friction, you would assume that the acceleration would be lessened. What friction is also not going to alter, we're going to discover, is the y direction analysis, right? But let's hold off on that just now. So let's look at the x direction. So what's pulling this down the ramp? Well, gravity's pulling it down the ramp, but since it's a ramp, only the x portion is pulling it down the ramp. And the force of friction is trying to prevent that from happening. And that's going to be equal to ma. And we discovered that this force of gravity is 60. The normal force, the frictional force, since it's kinetic, is equal to mu times mu k times F normal force. That's equal to ma. Now, I guess I should technically have said that this was mu k. That's a little sloppy, sorry, but you get the idea. And okay, well that's fine. And now we know this stuff, right? I'm going to move this mass calculation down. This mass calculation is still the same thing because I still have the 100 Newton box. So 60 minus mu 0.100. Now note, this normal force I had to have gotten earlier, right? And as I discussed earlier, if the angle of the ramp is higher, this normal force becomes less and less and less. If the angle of the ramp becomes more and more horizontal, or the angle gets smaller, this normal force will change and get larger. So that normal force component is important. And so now I can incorporate the gravity, see that it is, you know, impeding the force, the gravitation, so the net force is going to be less. And then if I solve this, I bring up my calculator, which I don't have up, because why would I? 5.10 meters per second squared down the ramp. And so my acceleration is obviously a little less. Now, what I'm not doing in these videos is I'm not asking you all kinds of wonderful follow-up questions, like what's the velocity at the top of the ramp if, that's a bit, I didn't mean to write it that way. What's the velocity at the bottom of the ramp, assuming that the velocity at the top of the ramp was 0, you know, how much distance had gone by, how much time had gone by, you know, all those wonderful, you know, acceleration formula situations, which I could have added on and can add on. But I'm not going to do for these videos, because you should be able to put those pieces all together. Okay? So, I hope this was helpful, and I hope it explains some things. If not, get a hold of me, and we will go over what you know, what you don't know, what pieces you're missing, and get you where you need to be. Okay? All right, thanks.